The distribution of galaxies. The image we're looking at is a map of galaxies. We are in the middle, looking out. These two dark regions here are where our own Milky Way blocks our view. So that's called the zone of avoidance. Whoops. Which sounds ominous. So this is looking up out of the disk of our galaxy and down out of the disk of our galaxy. And every dot you see here is a separate galaxy from the Milky Way. And what you can see is that although there is structure, overall we're seeing more or less the same kind of stuff in all directions. And so there are two things we can say about the distribution of galaxies within our own universe. One, we can say that all of the galaxies are isotropic. And as you see, the definition means the same in all directions. Now this is dependent on your location. So you are in one place, looking out. So in the two examples here, we are located in this location. And so in the first picture, that is isotropic. So we are seeing a mixture of spirals and ellipticals around us, and they are all moving away from us. And this is what we see. When we look out in the universe, we see all the galaxies moving away from us, and we see a mixture of spirals and ellipticals in all directions. The second image is non-isotropic. So again, from the Milky Way's point of view, in one direction we see mostly ellipticals. In another direction we see mostly spirals. And here's another cluster of spirals. And they're not all moving away. Some are moving towards, some are moving kind of past us, some are moving away. So it's a mixture of both galaxy types and galaxy motions. And so that would be non-isotropic. So our universe is isotropic. I just realized I put an E on that for no apparent reason. The other thing we can say about our universe is that it's homogeneous. So this is the same at all locations. So now this is as though you travel through the universe, you see the same thing no matter where you go. That green does not show up on the blue. So the first image is homogeneous. So as we look around, no matter where we go, we see galaxies, we see radiation, that's what the little squiggles are. And we see a mixture of both types of galaxies, and we see radiation wherever we go. The second image is non-homogeneous. So one part of the universe, you got galaxies. Another part of the universe, you've just got radiation. And you got a little bit of mixture in another place. So that would be non-homogeneous. So our universe, from our perspective looking out, is isotropic. We see the same thing no matter which direction we look. And if we somehow could travel through the universe, we find the same mixture of things at all locations. And so those are the two key characteristics of our universe.